This is lesson 2.5, graph characteristics, characteristics of graphs, I should say. All right. I can state and find the values of characteristics of a graph. I can state intervals of positive and negative, as well as increasing and decreasing sections of graphs. And I can find relative extrema of a graph. So maybe there's some new intervals in there, or some new vocabulary in there that you don't understand, like it's extrema. We'll talk about that. So here's kind of the vocabulary slide. Lets you know everything that you need to understand, and that's x-intercepts, which I think you understand already. But they're also referred to as roots, especially when we start talking about polynomials and solutions to polynomials. They're called roots, they're called zeros, they're called solutions, and so it's simply where the graph crosses the x-axis, right? So just like we've been doing in algebra. Y-intercept, well, you've done that as well, where the graph crosses the y-axis. Positive sections of a graph are the graphs above the x-axis, the section of the graph above the x-axis. So when we say positive and negative, we're actually referring to the y-values. Okay, the y-values being above or below. Above is positive, below is negative. Increasing, well, that's where the graph is going upward from left to right, and decreasing is where the graph goes downward from left to right. Extrema, they're the relative minimums or maximums, or the turning points on the graph. So they're high points and low points, but you're going to see, we're going to study functions that at the ends are going to go towards infinity, either positive or negative, but then you're going to want to discuss the humps, the peaks and valleys that you see between those two ends. And those are the relative minimums or maximums, just being the ones in the middle. Okay, so a relative minimum is a low point on the graph, and a relative maximum is a high point on the graph. And again, that's referring to the extrema in the middle, not the ends. Okay, so as you see graphs, you'll start to understand that a little better. So here's example 1. So just like I said, see how the ends of the graph go to negative infinity? Well, the section of the graph we're concerned about is this section between those two, that with all these labeled points. Okay, so what points on that particular graph then are the x-intercepts? Well, it looks like it crosses 4 times. So we've got an A, a C, an E, and a G. Okay, those are the x-intercepts. What's the y-intercept? Well, it crosses the y-axis at D. Okay, so the extrema are the peaks and valleys. So count the peaks and valleys here. Here's 1, 2, 3, 4, and 5. So this graph has 5 extrema. Which one of those is the maximum of those 5? Well, it looks like D is just a little bit higher than F, so we're going to say that it's D. And then the local minimum would be the lowest point of those 5, and that, I believe, is B. Now, these are tricky right here, so you got to be very careful. We're talking about increasing, decreasing, positive, and negative. So we're going to write intervals where these things are occurring. Okay, we're going to use interval notation, like we've studied. So it looks like the graph in this section right here, I'm just going to highlight all the sections I think are increasing. Here the graph increases from left to right, but then it makes a turn. Here it's increasing from left to right. And here it's increasing from left to right. I think it's decreasing here, here, and here. You agree with me? Now, how do we write those out? Let's write increasing in blue. So I'm starting at negative infinity, right over here at this arrow right here. I'm going from negative infinity to A, and I'm increasing. And then again from it's neither increasing or decreasing at the turn itself. So right there at point B, it's really not increasing or it's not decreasing. So it's not including B. So I'm going to parenthesis and I'm going to put A to B, and I'm not going to include either one of those because at A it's not increasing or decreasing, it's flat. Same thing at B. Oh, well, what am I doing? That's not increasing right there. It starts increasing again at B and goes to D. How about that? There we go. B to D, and it's flat at that one. And then how about E to F? Okay. Then it's decreasing from A to B. It's decreasing from D to E. And it's decreasing from F to negative infinity again. Okay? Now let me clear the graph off because we're going to talk about positive and negative. There we go. So positive sections of the graph are sections above the y-axis. Okay? Then negatives, let me find my color again. Negatives are sections below. So here and here. So these up here are positive, and these down here are negative. And so we just need to write those intervals. But we need to be careful because at A, it's neither positive or negative. So we need to write this first section of yellow highlight with two different interval notations. So it starts at negative infinity and it goes to A and does not include A. And then it picks up at A and goes all the way to C. And that's the positive. Actually, that's the negative section. Sorry. Let me erase that. Sorry about that, class. Let's try that again now. It's positive from C to E, and at E it's 0. And then it goes from E to G, where it's again 0. Now the negative sections, I'm going to go from negative infinity to A, then I'm going to go from A to C. All right? And then there's a section over there from G to negative infinity again. Okay? So that's a lot. All right? So you try example 2 and see how you do. And then I'll write the answers in for you here. Now they're giving values, okay? So you have to play around with values here on these. So hopefully you've done those and you stopped it. So I'm going to put a 3 there, negative 3, negative 1/2 on that. 1, 2, 3, and that's a 4. 1, 2, 3, 4, 5, that's a 5. And this we're going to say hits right there. And this one we're going to say hits right there. Okay, that'll help us with some values then. So this is negative 2, that's 2. Okay, so what's the x-intercepts? Well, I think they're negative 3, negative 1/2, and 4. Okay, I think the y-intercept is 5. There are 1, 2, 3 extrema. I think the local max is up at 7, 8, 9, 10. That looks like 10 to me. So the local max I'd say is 10. The local min is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'd say negative 12. Pretty close, right? And again, we're not looking for perfection here on these. We're just, it doesn't matter whether they call that negative 12 or negative 12.1. It's the concept that we want, right? So now let's do increasing. I think we're increasing from negative 2 to 2. And then we're increasing again from 4 to infinity. Okay? That's this section right here. There and there. And I'd say we're decreasing from infinity to -2. And we're decreasing from 2 to 4. All right? Then we're positive from infinity to -3. And then again from -0.5 over to 4. And then from 4 to infinity. And we're negative in just one stretch, -3 to -0.5. Okay? All right. Give this one a try. Pause the video and come back when you're finished. So that's a -3. That's -5. That's 5. That's 3. This is negative 1, 2, 3, 4. There's -5 there. +5 there. So x-intercepts, -5, 0, and 5. Y-intercept is 0. Extrema, 2. Local max, 5. Local min, -5. Increasing. -infinity to -3. 3 to infinity. So that's this section and this section. Decreasing, that's the other piece that we haven't named yet, -3 to 3. Positive, -5 to 0, 0 to 5 to infinity. And then negative is -infinity to -5. And then again from 0 to 5. Okay? So I can show you those. Let me erase what's on here. So we've got positive here and here. And we got negative here and here. Okay. All right. Example 4. This one's got some numbers on it. That's kind of nice. Pause the video. Start it back up when you're finished. So I got that point there, and that point there, and that point there, right? There's only one extrema, and it's the local max and local min, so both -6. Actually, we would say there's no local max. The local min's -6. It's increasing from that point, the local min, which is at -2 to 2. Excuse me, -2 to infinity. And then it's decreasing on the other side from -infinity down to -2. It's positive from -infinity to -7, and then it turns positive again over there at 3 and goes to infinity. And then the negative is just this middle pair here, negative 7 to 3. Then. Okay. All right, hopefully you're catching on to these. X-intercepts here. Yeah, you give this one a try again. Pause the video and start it back up again. So I'd say x-intercepts negative 3, and then we'll just call that 1.75. Okay, this point right here. And then 4. Then we got a y-intercept at 3. That's here. Extrema, there's 2. Local max is the one at 4, right up here. The local min's at negative 2. That's this one down here. It's increasing from negative infinity to 1. And then again from 2 to infinity. It's decreasing along just one stretch from 1 to 2. It's positive from negative 3 to 1.75. And then it's positive again from 4 to infinity. It's negative from negative infinity to negative 3. Make that look like a 3. There we go. And then again from 1.75 to 4. Okay. Example 6 is the last one, I think. Yeah. So pause the video, give it a try. Increasing. Couple if I put the other boundary in. There we go. And then again from, looks like negative 1.5 we're going to call it. Up to 2. 2 sections. Decreasing. Well, I put negative 4 there, but I think it's really negative 3.3 or negative 3.5, I think. See if I can squeeze in a negative 3.5 there again. So it's this point right here that I'm looking at. So negative 3.5. Okay. Then decreasing, so that's where it starts, decreasing. It makes the turn. And then it goes down to that negative 1.5 right here. And then it's decreasing from 2 to negative infinity. Then positives, negative 4 to negative 3. A little hump there. And then that hump from a half to 3. And then negative, it's negative infinity to this negative 4. And then it starts going negative again at negative 3, all the way over to a half. And then it's negative from 3 on to negative infinity again. Okay. Yeah, so I could imagine just one of those questions on the test or quiz because, you know, that's several questions, several points. 1, 2, 3, 4, 5, 6, 7, 8 points. Or is that 9? I can't even count. Yeah, it's 9. So there's an assignment there, characteristics of graphs. It's an exit ticket. That's a form. And then there's a delta math assignment on that as well.